Hi guys, this is a continuation of yesterday's notes on solving radical equations and checking our answers for extraneous solutions. The first thing we always want to do is to isolate the radical and then cancel that radical out by squaring both sides because squaring cancels out square rooting, or cubing both sides because cubing cancels out cube rooting, or etc. We want to solve for the variable and we want to check all solutions for extraneous roots. Here we go. So the first rule is to isolate the radical. Well, notice in this problem we actually have two radicals. So we're going to pick one of them. We're going to isolate one of them. So I pick this one. I want to isolate that one. So I'm going to add the square root of x to both sides. And I would get the square root of x minus 3 is equal to 3 plus the square root of x. All right, now the second step says I want to cancel out the radical. So to cancel out the radical, a square root, I'm going to square. And as you know, what we do to one side, we always do to both sides. So if I'm going to square the left side, I've got to square the right side. Okay, squaring cancels out square rooting. These two cancel each other out, so we end up with x minus 3 on the left equals, squaring means to take something times itself, so I'm going to take 3 plus the square root of x times itself. Now this is a FOIL problem, so I'm going to take 3 times 3, 9, 3 times the square root of x, 3 radical square root of x, square root of x times 3, plus 3 square root of x, and the square root of x times itself. So when you take the square root of x times itself, that would be the same as saying the square root of x squared. We know squaring cancels out squaring, so that would just give us plain old x, whatever is underneath our square root sign. And on the left side, we have x minus 3. So x minus 3 is equal to, combining like terms, I would have 9 plus 6 square roots of x, because 3 square roots of x plus 3 square roots of x give me 6 square roots of x, plus x. Now I want to solve for x, and notice I still have a radical in my problem. So now I'm going to isolate this radical. I want to get it all by itself. So let me subtract 9, and subtract x from both sides. So I have negative 12 equals 6 times the square root of x. Divide by 6, divide by 6, and now we're down to negative 2 is equal to the square root of x. Well, in order for this to be true, it can't be true. Right here, I know that this is, we call this a reject. We're going to reject this because the square root always comes out positive. Like square root of 25 is 5, square root of 49 is 7. We can't have a square root of a number and come out with a negative. So that is a reject. But say we didn't notice it and we just continued on our merry way, and we're going to square both sides to cancel out square rooting. And we're thinking this looks good. I get 4 equals x. Well, when I take it back up here and I plug in 4, and I always check my answers, it looks good so far. 4 minus 3 is 1. So I have the square root of 1 minus the square root of 4. The square root of 1 is 1, minus the square root of 4 is 2. So I get negative 1 equals 3. That is not true. That means that this is an extraneous solution. So no solution, in other words. Let's move on to one more problem, and then I'll cut you loose and you can start doing your homework. Again, notice that we have two radicals and we need to isolate one of them. I choose to isolate this one. So I'm going to move the square root of x plus 6. I'm going to add square root of x plus 6 to the opposite side. Square root x plus 6. So on the left side of the equal sign, I have the square root of 2x plus 5 isolated equals 1 plus the square root of x plus 6. Looking good so far. To cancel out square rooting, I square, but what I do to one side, I've got to do to the opposite side. So, whoops, my little squared wants to just travel along with my page. All right, so squaring on the left side, squaring cancels out square rooting, so that gives me 2x plus 5. On the right side, I'm going to have to FOIL the binomial. I'm going to have to take 1 plus the square root of x plus 6 times itself. All right, so we have 2x plus 5 equals 1 times 1 is 1. 1 times the square root of x plus 6 is the square root of x plus 6. And that's a 1 out in front. You have 1 square root of x plus 6. The square root of x plus 6 times 1, again, you have 1 square root of x plus 6. And the square root of x plus 6 times itself, again, when you take something times itself, that's the same as squaring it. So squaring cancels out square rooting. So we would just simply get x plus 6. When we combine like terms on the right, we end up with 1 plus 6 is 7 plus x. 1 square root of x plus 6 plus 1 square root of x plus 6 gives me 2 square roots of x plus 6. Okay, notice I still have a radical, so I'll need to isolate my radical again. So I'm going to shift my 7, so I'll subtract 7, and my x, so I'll subtract x from both sides. 2x minus x is x. 5 minus 7 is negative 2 equals 2 square root x plus 6. All right, I feel like we're doing pretty well. Now we have to cancel out square rooting again. So to cancel out square rooting, we square. What we do to one side, got to do to the opposite side. So we have x plus 2 times itself, and we have 2 square root x plus 6 also times itself. All right, let's FOIL on the left side. X times x is x squared. X times 2 is 2x. 2 times x is 2x. And 2 times 2 is 4. Equals. On the right side, this is not a binomial. Sorry, I'm going to redo my square root. This is not a binomial times a binomial. This is not a FOIL problem. It's kind of like 2x times 2x. You multiply the 2 times the 2 and get 4, and the x times the x and get x squared. So it's kind of like that. It's the 2 times the 2 gives you 4. The square root of x plus 6 times the square root of x plus 6 gives you x plus 6. Because when you square a square root, you cancel out your square root. So now we've got x squared plus 4x plus 4 on the left equals 4x plus 24 on the right. We'll shift everything to one side so we can factor it. So let's subtract 4x, and while we're at it, let's subtract 24. Subtract 24. So we come down to x squared minus 20 equals 0. I see I made a small error, guys. When I wrote down x minus 2, I should have written x minus 2 times x minus 2. I wrote x plus 2. So let me go back and let's just fix that real quick. This is not going to make a huge difference. So I would get minus 2x instead of plus. And I would get a minus 4x right there, minus 4x. And the rest would be the same. Sorry about that. All right, we've got x squared minus 8x. And then we've got minus 20 equals 0. And we factor that so that we can set our factors equal to 0. X times x gives us the x squared. Let's see, I'm thinking negative 10 and a positive 2. So x equals 10, x equals negative 2. Now, one of the most important parts is the check. So we've got to check our answers. So let's go back up here to the problem. And I'm going to try 10 first. So I've got the square root of 2 times 10 plus 5 minus the square root of 10 plus 6. And then we'll see if it equals 1. So this is the square root of 20 plus 5, which is 25, minus the square root of 16, and we'll see if it equals 1. The square root of 25 is 5, minus the square root of 16 is 4. 5 minus 4 equals 1. Check. That works. 10 is a solution. Now let's see if negative 2 is a solution. Question mark. We'll see. So we've got, let me see if I can find a little spot. The square root of 2 times negative 2 plus 5 minus the square root of negative 2 plus 6, and we'll see if it equals 1. So that is negative 4 plus 5 minus the square root of, that would be 4. We'll see if it equals 1. Negative 4 plus 5 is 1 minus the square root of 4. The square root of 1 is 1 minus the square root of 4 is 2. 1 minus 2 is negative 1. Negative 1 does not equal positive 1. So that means that negative 2 is extraneous. All right, that's it. If you're pre-AP, stay tuned for a second video on some more complex problems. Have a good evening, guys.